Hello, friends. This is Jim here with Science Talk. Um, I've done two prior videos discussing the very unusual summer of 2019 that uh, took place here in Alaska. So I thought I would continue with the latest data that's come in that takes us through the rest of the summer into the autumn and now early part of winter. I'm going to do this over two videos because if I try to do this in one video, it's going to be whoppingly long. So I'm going to break this up into two videos and kind of taking it uh, through about October, November, beginning of November or so, and then to the latest information as of this date, which I'm recording this is November 22nd. So I cover basically several major areas: air temperature, sea surface temperature, and what's going on with the sea ice. And when there's some notable information about precipitation, I will include that as well. So let's get to it. So let's look here at the Alaska statewide temperatures from 25 to 2019. This is the June to August average temperature. Now, if you look here, the red dots are the 10 warmest. The 10 coldest are the blue dots. The black dots are pretty much anything in between. And this is your trend. If you notice, starting about around 1971 or 2, the trend remarkably starts to increase. In other words, before 1972, the average temperature was pretty much about 50.2 degrees Fahrenheit. It now has started to increase so that projections are that it will be over 52 and a half degrees approximately Fahrenheit, or if you want to look at it, 11.4 degrees Celsius. That is significant. That's 2 degrees. It's two, if you look at it from here, that's 10 to 10 to 11 and a half. That's 1.5 degrees Celsius, or about no, not quite 3 degrees Fahrenheit, 2.5 degrees Fahrenheit. But the trend is unmistakably clear. Summer temperatures are increasing, and you can see the 10 warmest years have occurred from basically 1976 onwards. This is the second warmest summer in the past 95 years. Okay, let's see if I can I'll move that up to there. That should get me out of the way, so it won't block any of the stuff there. Since 1997, there have now been 7 summers warmer than any summer was between 25 and 1996. Right? Here is 1996, approximately. Right there, 1, 2, 3, 4, 5, 6, 7. These are the 7 being referred to. This is a clear example of systematic environmental change. What was unheard of is now routine. The data source is NOAA and NCEI. Rick Tolman provided this information. As has in the past prior videos, a lot of the graphics that I present here are courtesy of Rick Tolman and Brian Brettschneider, both who are meteorologists working for the National Weather Service associated with International Arctic Research Center on the University of Alaska Fairbanks campus. Brian sometimes is actually down in Anchorage a lot. So, but they keep on top of this, and they're kind enough to share this information. Not wait until it gets into peer-reviewed journals. So they share this information to kind of give us a hot off the press approach. So, there we go. So now let's look at the climate division's temperature ranking since 1925. This is for the summer of 2019. Summer 2019 for Alaska as a whole was the second warmest on record. We've already mentioned that. For South Central and Southwest Alaska, it was the warmest. That's what you see indicated in red. Most other areas, a top 5 summer. Okay, that includes most of the state. This is the coolest portion, but it's still warmer than average. Right? And this is where you start getting over to the Yukon Territory, uh, that kind of stuff there. Northeastern Alaska, but not quite up to the coast. So it shows you what's going on here. And as I'll show you later on, a lot of this is related to lack of sea ice, open waters. Okay, now I just kind of I throw this in here as a comparative to what's happening around the rest of the upper northern hemisphere. Now, a lot of people often say, well, why should we care about what goes on in Alaska? It's just Alaska, right? You're crazy to live there anyway. Well, the Arctic is the fastest warming region on the planet. We have the data for that. Kind of think of Alaska as the canary in the coal mine. A lot of people live here, relatively speaking, and we're sitting here collecting the data and we're seeing what's going on. But what happens in Alaska affects the rest of the planet. It's just, what happens in the Arctic affects the rest of the planet. And so this is basically an indicator of things to come. Now, with the climate changes going on here, the PDO, Pacific Decadal Oscillation, the Arctic Dipole, AD, Arctic Oscillation, the AO, and the North Atlantic Oscillation, NAO, are all being affected. Now, I just completed a video series discussing all these oscillatory systems of the planet. These are all being affected by climate change. If you have not done so already, please do check out those videos. There's about 7 of them, 8 of them, 7 or 8, something like that. And it's worthwhile they're lengthy videos, but it's worthwhile to sit through them and see what's going on, the factors that affect what the cycle's all about, what the cycle's all about to begin with, and then the factors that affect them. That's basically, the important information to glean from it. I did one on rotating systems, just so you understand what rotating systems are all about, so that you understand, what Coriolis does, what the conversion divergence zones are, upwelling, downwellings, updrafts, downdrafts, that sort of stuff. The Ekman spiral, Ekman transport, etc. So some of them can get a bit techno, but hey, you people are smart. You follow along. But please do check those out. So what are we looking at here? Okay, basically, you can see here's those little islands, and then you got Scandinavia, here's Europe, Northern Africa, going over into Eurasia, etc. So we're looking at a 2-meter temperature anomaly, okay? And that's July, August of 2018, June to August 2018, June to August 2019, okay? And then World Climate Service Temperature Anomaly Outlook, that's who's responsible for providing this information, June, July, August, and then June, July, August. So this is for 2018, this is for 2019. What do we see here? It's above normal. It's freaking warm. Okay, everything's warm. Now, if you look carefully, however, you can see that the warm is stressed. Here's Novaya Zelnya, right? The new Earth here, Zelnaya, right? So as we're getting into the Barents Sea here, and the Laptev Sea here, you can see it's warmer up here, right? So here's like Finland, here's Russia. So Murmansk, the sub base is about there, right? So it's warmer here. We see a switch back here where it starts to get a little cooler. Why is that? That's because of the North Atlantic Oscillation in conjunction with the Arctic Oscillation, going from positive to the negative phase. As I said, you can understand better what's going on with these graphics if you have a background, at least an introductory background to these oscillatory systems. Okay? But overall, we can see that it is warmer. Warm, cool, warm, right? And this is the big thing. It got cool here. And basically, the Middle East region here, Turkey, right, Middle East, went from warm to cool. So that's due to the NAO and the AO switching from one phase to the next, to the other. Now, this is global sea surface temperatures by decade since 1900 using standardized categories. Each color has an equal chance of occurrence at any location in any decade in an unchanging world. That's what's meant by using standardized categories. It is to eliminate bias. Okay? It's to eliminate bias. So you got the 1900s, 1910s, right? It's all by decades. And what do you see happening? Look at the bottom. Just look at the bottom. So first of all, let's look at the scale here. If it's about light blue to this darker green, that's pretty much around average, what the baseline would be. As we get into the deep purple, one of my favorite bands, it's definitely on the cooler side. Okay, this is deviations from the 1900 to 2018 average. And this, by the way, is in Celsius. Okay. And then when you get to the deep red here, that gets what's really, really warm. So as we can see here, there is a trend, especially off the western coasts of the Americas, of it being cooler. Around Antarctica being cooler. Got a couple, isolated warmer spots here and here. But where it's white, by the way, white means it's average, no deviation. It's not like there's no data. It basically means it's no deviation. Look at the Arctic Ocean, it's cooler, right? Everything, when you see through the 1930s, it's cooler, except we got a little warm spot here in the North Atlantic, and that's due to the NAO and probably the Atlantic multi-decadal oscillation, the AMO. So we see that here. And then in the 1940s, it starts getting warmer. Now, some of this could be ENSO events. But now look at what starts happening in the 1970s with the Southern Ocean. Now here's in the ocean, Southern Ocean is around Antarctica. It starts really heating up. And then just look at this. The oceans are hot. Now, when you think about the specific heat of water, and you're going to basically something on the order of like 1.38 or more hotter than the average, that is an incredible amount of energy that has been put into the system. The ocean absorbing the heat, is why it's not as bad as it could be for us terrestrial creatures. This is basically saving our asses. But keep in mind, as you increase water temperature, the solubility of gas decreases. So eventually, all the CO2 that's been absorbed by the ocean is going to start outgassing back into the atmosphere, further jacking up the levels. So this is serious stuff here. It's right here. It started in the 70s, and it's just really intense that practically all the oceans of the planet, except for some isolated spots around Antarctica and up in the Arctic Ocean, is much warmer than average. That is a very ominous indicator. And that, of course, changes the water chemistry. It changes the stratification of the ocean, where now you can start having a shallow permanent pycnocline, preventing nutrients from getting mixed into the surface layer, which will inhibit photosynthesis, and that puts surface layer pelagic ecosystems at risk of collapse. So this is this is an extremely troubling trend. Okay. So let's do a little, compared to the previous year, the summer 2019 was cooler in Scandinavia and the British Isles, despite similar heat in Central Europe. The shifting focus of the unusual warmth was predicted successfully by a forecast for the two summers. Read more here. This is the URL right here. And this is the group, that World Climate Service that I'm referencing here. They're doing a lot of really excellent research. They basically have provided some interesting graphics and information. So, yeah, definitely might want to check this out. So again, you can always pause my videos and ruminate on the material being presented. Want to jot down the URL, you can do so. Yeah, that's why I put them up here. It's for you guys to go check them out. Okay, back to Alaska. Utqiagvik is basically Point Barrow. Utqiagvik is the native name. Most consecutive days per summer with low temperature above freezing. Now, the Arctic is defined as the average daily temperature of 50 degrees or less in the summer. That doesn't mean it cannot get below freezing. Can't say at night because the sun shines 24/7, but when the sun is lower in the sky, there's nothing saying that it can't cool down. So again, just like I showed you earlier with the 95-year trend here, it's pretty steady until about 72 or so, and then it starts going up. So we see the exact same thing at Utqiagvik, Point Barrow, as we did for the entire state. So this is the smooth average, and these are highs and these are values for specific years. Monday is the 76th straight day with temperature staying above freezing. Previous record was 68 days in 2009, so 10 years ago. So that's what this is on the vertical axis, the number of days above freezing consecutive. And here we have it, 69, 2009, dips down to about 62.3 or so in 2010, goes back up to about 62 or so in 2011. And then look here at 2019, it's way up there. You've had some other spot, it's 50 and so on. But when we start seeing 4 years of the highest consecutive values within a decade, that's definitely a trend. And this information is updated through September 9th of 2019. Okay, Thursday evening, the temperature dropped to freezing at Utqiagvik for the first time since June 25th. That's 85 days above freezing. That's the longest such a record. It blew out the prior record. Prior to the 1990s, it was not uncommon for the longest above freezing streak to be less than 10 days, right? Look at most of these trends here, right? These blue bars here, right? Less than 10 days. If you want, you can be generous, say less than 20 days. Point is, look at the great majority, then you get these 4 years where it's starting to really jack up. It'll be interesting to see what 2020 brings. September 2019, by far the warmest at Utqiagvik. Average temperature of 4.9 C is about 4.8 C above the 81 to 2010 normal when it starts warming up. So it's even warmer than the warming average of the prior 30, I guess that would be 30 years. Previous record of 3.2 C in 2007 and 98. Big factor, warm Chukchi and Beaufort Sea. They didn't freeze over, open water. You have latent heat energy being given off from the oceans, and that gets into the atmosphere. And Point Barrow is right on the ocean. And again, here's your trend. You see, it almost looks like a hockey stick graph. But there it is. You got the coldest and you got the warmest. And there's 2019. Boing. Okay. So the previous one was just for September. Now let's look at the January to September 20 average for 21 to 2019. So this is basically almost a 100-year record. Since January 1st of 2019, right, there's your average daily departure that I just mentioned in the previous slide. Days above normal, 87%, in others, almost a full year. Days at below normal, only 13%. The first 8.5 months of 2019 at Utqiagvik have been almost inconceivably mild. So far, typical 2019 day is 8 degrees above the 81 to 2010 normal, 87% days warmer than normal. Through September 20 this year is 2.5 degrees Fahrenheit warmer than next warmest year of 2016. And again, you can see here's 2019. Right, here's some of the previous years. Notice the cluster: 1, 2, 3, 4, 5, 6. We have 8 of the warmest years in the last decade since 2010. It's very alarming. High temperature Tuesday, September 10, 2019 at Utqiagvik, least a record tying 55. This is the 6th day this month with a high greater than a 55 Fahrenheit, most in any September. So basically what this is saying is that they've had at least 6 days of a high temperature, 55 degrees Fahrenheit or warmer. Previous record was 4 days in 95. Vast majority of Septembers have no days so mild. Because we're approaching equinox, which, the tilt of the axis is basically backing away so that the direct sun energy, because the axis is tilting away, the sun energy is not hitting as directly on as it would when it's tilted towards the sun. So basically, the same amount of incoming radiation is now spread over a wider area on the surface. When when the sun is tilted this way, right, it really is you're going to concentrate the energy on a smaller area. You start tilting it back and this energy spreads out. That's what happens as the axis tilts. So we should be cooling down, and it's not. Part of it is the open ocean, but also just what's going on. Near record high temperature of the North Slope on Saturday afternoon. Dead horse at 47 degrees Fahrenheit is a new record for September 28th. It's practically the end of the month. Kuparak, 46. Utqiagvik, at least 45 degrees, record of 46 F. So this is September 28th. That's a specific date. Right? Utqiagvik was at 45. Is Wainwright, Umiat, Saglan, is Dead Horse. Dead Horse is basically Prudhoe Bay. And Kaktovik, which is actually, it's an island that's just off the coast. So it's not on the main continent itself. Oak Crow is in the Yukon. So Kuparak is about here. It's actually they want to drill there, but there's a lot of fight going on because it's a major lake there. That's a major stopover point for migrating birds. Over here is the Kotzebue Sound. So it's, this is the North Slope of Alaska. This is the Arctic Ocean right here. Here's the Chukchi. Here's the Beaufort Sea. This is the North Slope of Alaska. Right? Brooks Range is here. We get and it's just so warm, almost into October. This is really unheard of. Now let's start looking at sea ice. As the 2019 Arctic-wide sea ice seasonal minimum extent approaches, let's review how much has changed. Typical September extent is now half of what it was before 1980. Let that sink in. Basically, you're having half the amount of ice. This is based on Walsh et al. In the 2016 paper. Here's a URL if you wish to examine it, and updated with the NSIDC data, National Snow Ice Data Center. They're located in Boulder, Colorado. And this is John Walsh, excellent scientist, really, really super nice guy. So we have sea ice extent. Okay, this is recorded in 10 to the 6 is 1 million. So this is recording 1 million square kilometers. So basically this would be 8 million square kilometers, 4 million square kilometers, so forth. So when you look at this, okay, September, it pretty much what you would expect. This is from 1850 to 2018, and then starting at about, let's be generous, starting about 1980, it just starts diving. We start losing the sea ice. And as you have more and more open water, it absorbs more and more heat. That's less and less albedo. You're creating, wait for it, positive feedback loop. Okay? And that's basically what we're seeing here, that the sea ice is the extent the area covers is declining, which also means it's less and less multi-year ice, because a lot of it is not lasting entirely through the summer to have more added on next winter. A lot of it melts off, so you're losing multi-year ice, which is significant. In case you're wondering, sea ice is very, very far from Alaska. This is September 10th. Okay. This is the sea ice, this white stuff here. This light blue is thin sea ice. This is like first year sea ice. Remember I just said about less and less multi-year ice? Well, basically the multi-year ice is now being restricted further and further closer to the North Pole. Used to be you would have multi-year ice down to here, and then the first year ice here. No. Here is Utqiagvik, right? Here's Alaska, here's Point Barrow. Here's the Chukchi, here's the Beaufort Sea. Where is the ice? This is September 10th. It should stop you freezing. The ice is not there. That's open water. Open water gives off its latent heat. This is why this is so warm up here. This is as of September 10th. Now, so that was ice. So now we're going to look at sea surface temperatures. Now, obviously, if you have warm sea surface temperatures, guess what? The ice is not going to freeze. The water's warm, so the water's not going to freeze. Sea surface temperatures around Alaska shown as standardized anomalies every month since 2011. Anything in yellow or orange or red is significantly warmer than normal, and red is exceptionally warm. Red is cooking. So now, okay, so we have the months here, January through December, right across the top here. 2011, 2012. What do we see starting? This is, off the coast of California, right? It's quite warm there. Part of these is also the Pacific Decadal Oscillation. Right? Kind of a cooling trend here, right? This is the that's the Western Pacific. Eastern Pacific's here. So this is like towards Japan and Asia, over that direction. But as you can see here, looking through this, we see a very clear trend, especially for the last 2 years. It's warming up. 2015 was an exceptionally warm year for the Pacific Ocean. It's got some cool spots. And if you look, you can see the Pacific Decadal Oscillation. Okay, let's look at, for example, let's look at February 2013, 2015, right there. Cool, warm. Warm, but cooling down. Now it's cool again. So you can see these cycles. What's happening is that, oops, didn't want to do that. What's happening is that the frequency of the switchover is less. And when it stays in one phase, the warmer phase, it stays there longer. And the latest data as of August of 2019 shows warmth right through the Bering Strait. You can see that right there. This is right there where the cursor is. That's the Chukchi Sea. That indicates it's a very warm summer in the Chukchi Sea. You can see that here. You can see that there as well for July. So again, you can pause the video and really look at these figures, these graphics, and really study them. If I was to talk to you about in detail what's going on, that'd be an hour in of itself. And you probably would be bored listening to me do that. But you can see clear trends here of warming. But keep in mind, we see it cool and then changes. Keep in mind the various oscillating systems I discussed with you. So that's why I think if you have not seen those videos, please watch them. It will help put this in perspective. Because it is important for us to basically tease out the typical signals, natural signals, if you will, from actual anthropogenic effects. That's the key here. And when we do that, when we take into the cycles the switch between positive and negative phases, cooling, warming, etc., oftentimes we're left with, we'd have a definite anthropogenic signal that is warming the situation, be it air, water, what have you. The waters of Bristol Bay have been much warmer than normal all summer, and really shows in the Dillingham temperatures. Since June 1st, only 3 days below normal, with the 103 days average almost 6 degrees Fahrenheit above normal. Okay? So, summer 2019. Now, Dillingham is basically out in the Aleutians. So, here are the dates starting from June 1st. And at the time of this was put together, it was September 11th. And you see only 3 days where it's cool. Okay, so this is deviation from normal. Now, the 0 is normal. So if you see this little point here on July, that looks like July 27th or so. Let's see, 21, 2, 3, 4, 5, 6. Yeah, July 27th. That temperature was almost at normal. But you can see how much warmer it is. Look what's going on in July. A lot of warmth here, and then a late pulse in August of warmth. Okay, Fairbanks Airport. High temperature today, September 13th, 73 F, or almost 23 degrees C. Only 7 years since 1904 have had a temperature this high or higher this late in the season. Most recently, 2014. Since 1904, the average date of the last 70 degrees Fahrenheit or higher is August 29. This is basically 2 weeks later. Fairbanks is set to record the greatest number of what we call base 40 degrees Fahrenheit growing degree days, which is a degree days is a measure of accumulated warmth in a season. Currently third highest, but the forecast for the rest of September indicates this will exceed the current record set in 75, which is that data point there. So it goes from 1930 to current, and degree days here based on 40 degrees Fahrenheit, right? GDD, growing degree days. And this is the regression line that's fitted through the data, and it shows a clear positive slope. So it shows a clear increase that's going on. Which means, in essence, what the take-home message from that is it's getting warmer and the warmth is accumulating. And that warmth can be retained for longer, thereby slowing down the cooling process as you move into autumn and winter. Utqiagvik up to 42 degrees Fahrenheit, 6.1 C through 4 p.m. Alaska daylight time, ties a record high temperature for September 29 set in 2016. Maybe that doesn't sound too warm. In fact, just 2 days in the past century have been warmer than any later in the year. Just piling up the record accumulated thaw degrees days, it's the gift that keeps giving. That's Rick Toman. He kind of has a wry sense of humor. Influencing permafrost warming and thawing, and the active layer depth and erosion susceptibility for a long time to come. Basically, as you have a degree days accumulating and the thaw degree days accumulating, the active layer is another way of referring to the seasonal thaw layer of the permafrost. Notice that layer, the upper layer of the ground that thaws out every summer. Basically, what they're saying is it's getting deeper because the warmth is now being absorbed, being accumulated, and so it's penetrating into the ground so that the active layer becomes thicker, which means the layer where you hit the permanently frozen stuff is going deeper. It's not as shallow. So, and the trend is, of course, this will keep happening. Now, what does that mean? It means as you thaw out the permafrost, guess what? Methane, right into the atmosphere. So again, you notice that everything pretty much starts from some point in the 70s, starts going up. Smooth average thaw degree days. It's just been accumulating. First half of September was the warmest of record at these long-term climate sites: Utqiagvik, Prudhoe Bay / Dead Horse, Kotzebue, Nome, St. Paul, McGrath, Iliamna, and Anchorage. You go to Barrow, Utqiagvik, there's actually a weather station there. It's a little shack. It's been continuously in operation since the late 40s. So we have good long-term data there, measuring all sorts of meteorological parameters. So it's a treasure trove for data information. September 2019 average temperature were above the 1981-2010 normals all across Alaska, especially on the North Slope. Warmest of record at Utqiagvik and Dead Horse, Southern Bering Sea region. Cold Bay was the warmest, St. Paul the second warmest. Okay, here's Cold Bay, out in the Aleutians, the snotty Aleutians, and here's St. Paul, this tiny little speck of an island. You talk about being in the middle of nowhere. There you have it. But look at this map here. Everywhere has a plus temperature, meaning that these are the temperatures, the amount above normal. Right? There's not a single minus in here. Not a single minus. Some areas were less warmer than normal than other areas, but the point is it's warmer everywhere. So, September, another mild month in Alaska, and Anchorage, the 19th consecutive month with above normal temperature. 19. That's well over a year. Yeah, that's 18 is a year and a half. So this is over a year and a half of above normal temperatures. Drought improved over southwest and south central, but persisted in the panhandle where rainfall was below normal. That's another issue that usually the southwest. Okay, this is the southwest out in the Aleutians and the panhandle. Basically, what wraps around the Gulf of Alaska, as you would expect, gets a shitload of precipitation. Well, they didn't actually, I like the little cactus here, they indicate that they're actually in a drought situation in southeast of all places. Juneau, the joke is, when you have a sunny day, everyone quits work and enjoys the sunshine because usually it rains there all the time. Well, it's been a little on the warm side. So some of the highlights here. Sea ice, 150 to 500 miles from Alaska all month. That's from September. Supposed to be pretty much start freezing close to shore. Utqiagvik, warmest September. Dead Horse, all-time September high temperature. Kotzebue, fourth warmest. Fairbanks, first freeze September 22nd, ends the second longest growing season. Usually, the first frost be in August. Golcana, third warmest September. Emonic, 1 inch of snow September 24th. St. Paul, second warmest. Cold Bay, the warmest. King Salmon, fifth wettest. Right, so this is what we're talking about where the drought improved over southwest. The sunny gets some sort of precipitation. Kodiak was fourth warmest. Anchorage, fourth warmest. Yakutat was the warmest July-September run. And then Juneau, 5 days of record high temperatures. And then, of course, southern southeast, severe drought continues. highlights, lowlights, whatever, but there's a summary of some of the significant events in September around Alaska. Now let's look at sea surface departure. Sea surface temperatures around Alaska remain very warm as we head into autumn. Large departures in the Chukchi mean a delayed return of sea ice to certainty, which will in turn slow ice formation in the Bering Sea. Okay, here's the Chukchi. See how much warmer it is? Look at your scale. This is in degrees C. So we're talking 5-6 degrees above normal. Okay, that's over 10 degrees Fahrenheit. In fact, that's almost 11 degrees Fahrenheit. 6 times 1.8 is 10.8. So that's 10.8 degrees Fahrenheit above normal. That's really warm. And of course, that's going to, you can see it's trickling through in some parts through the Bering Strait. Gulf of Alaska, a little bit warmer, about half a degree C or so. Sea surface temperatures around Alaska remain above normal. This is September 6th through 12th. Okay. The previous was August 30th to September 5th. I'm kind of giving you a running scorecard here. So now we look at the next week. Remain above normal. Offshore North Slope temperatures are extreme. Wainwright to Prudhoe Bay. Wainwright is about here. The Prudhoe Bay is Prudhoe Bay. So talking about this portion right here, right? Chukchi, so on. Storminess in the Bering Sea has lower departures, especially Bristol Bay region. Otherwise, if it was calm seas, it'd be warmer. So now through September 12th, it's still extremely warm up here in the Chukchi. Now we look at, for the whole of September. Again, we see well above that, above normal. The comparatively warm waters of the Western Beaufort and Chukchi Seas ensure a very late freeze up, even by the standards of recent years. In other words, this is even a really warm year. Because the trend for the last 4 decades has been ice melts sooner in the year, freezes later in the year, sea ice is not as thick, less multi-year ice, and less sea ice volume. That's been the trend, to generally summarize what goes on with sea ice. Average September sea ice concentration just north of Nuvik since 1920. More uncertainty prior to the 50s because of how the data was collected, recorded, that kind of stuff. But it's always something is happening here. Yeah, boink, it's dropping. And pretty much almost to it's basically zero. There is no sea ice here. Right? 2010, no sea ice in September. This is average. Look, I'm indicating the trend line here. Now, these are important graphs here. Sea ice extent has been below even the 2010s median. Remember, median is the 50th percentile. Okay? So we have the 2019, which is in the solid red, the 1980s median in blue, 1990s median in turquoise, as that color is. Orange is the 2000 median. Lavender is the 2010s median. And yeah. So you can see that, here's the 1980s, here's the 1990s, here's the 2000, here's the 2010, and here's 2019. And what do you see? Less and less ice. That's the trend, less and less ice. Also notice how the melting starts earlier. That's indicated right here, right? See, this is still light sea ice here. Now it's starting to melt out earlier. The volume drops down. Very telling. This is basically a 40-year data set. We can, again, show it again. Ice extent in the seas north of Alaska continues to decrease. As of September 14th, both the Chukchi and the Beaufort extend at the lows of the season. Weather models have a windy week ahead north of 74 degrees north latitude, which may or will push existing ice around. Okay, so again, these are individual years. The black is the 40-year median, so that's the 50th percentile, right? So 50, so this is 40 years, so 20 years above it, 20 years below that line. Okay? 2018 is in red, and then 2019 is in green. I would actually prefer, just to be consistent, they switch the colors on those two. Be that as it may, but you can see it's 1, 2, 3. It's about the fourth lowest ice extent on record. Right? And this slice here is showing where the information is coming from. A little hard to read, so I'm not going to, but that's where this is. It's a combined Chukchi and a Beaufort. Right? And then, so if you look at the previous, through September 15th, and now through September 21st. So the previous slide showed it through September 14th, 15th, kind of reaching its lowest right there about September 16th, and now it is starting to increase the extent it covers. So the ice is starting to freeze up, but it's quite late in the year. Sea ice extent in Beaufort and Chukchi is still decreasing as of September 18th. Only 2012 and 2016, recent years, had significantly lower minimum extents. Current extent is only 37% of the pre-2000 average seasonal minimum. So sea ice extent in kilometers, right? This is the most, what you see in red, and now here's 2019 at black. What they're saying is 2012 and 2016, that's these two data points there. So that's actually, you can now say third lowest extent. And these other dots is just tracking the progress. It's just another way of presenting, probably in a less cluttered manner than the previous slides. And this is through September 17th. So the Arctic sea ice minimum was reached on September 18th, tied to second lowest in the last 41 years. Now you see, there's a clear trend. Ice melts earlier, freezes later, doesn't extend as far south. Thickness is decreasing, less multi-year ice, volume is decreasing. That's the trend for the last 4 decades. Again, showing average late summer, July through September, the extent in Chukchi was the lowest of record. And then with all that extra, meaning that instead of having ice on the water, you have open water. Ice reflects sun energy back, albedo. Now, no ice, water's going to absorb that energy, warms up the upper layers of the water. That's why we have very warm sea surface temps. So again, average extent with the smooth median, 50th percentile, and the ice extent given in square kilometers. The closest sea ice concentration, greater than or equal to 15% to Alaska, as of October 1st, is about 250 miles, 400 kilometers northeast of Kaktovik. This is what you see in white is the sea ice. This is all open water. October, having this much open water is unheard of. Starting to see some precipitation, right? Some snow there. This is the Brooks Range. That's to be expected. But still, having all this open water is unheard of. And its precipitation is coming from open water giving off its energy, giving off its moisture, and it comes down, precipitates the snow, or helps it at least. August 2019 was the second warmest August on record globally. Here is the distribution of temperatures as standardized departures. More than 50% of Earth fell into the significantly above average category. So the black curve here is the expected normal distribution. When you look at this, what do you see happening? It's being skewed in this direction. We actually say, it sounds backward, but we actually say skewed left because the normal distribution would have a longer tail. Well, the distribution would be skewed so that it has a longer tail to the left, not to the right. If the data was this way, then it'd be skewed right. I know it's kind of backwards. That's how it's described in statistics. So you have this being pushed. You're pushing the curve this way, the distribution this way, when if you compare it to the expected curve, you have a longer tail on the left side, so it's considered left skewed, which means that everything's gone to the right. Backwards thinking, I know. I don't come up with this stuff. But, and Brian does a lot of these analyses. It does really excellent work. Temperatures just getting warmer. That's what this is telling you. Temperatures are getting warmer. That was for August. Fairbanks is now above normal for precipitation for the entire year. If nothing more falls in the next 103 days, 2019 will still be a wet year. Almost 12 inches of precipitation since January 1st. Interior Alaska is supposed to be considered a semi-arid desert. It hasn't been the last decade or so. Okay, so want to give credit to gentlemen and other agencies that make possible all this information that I put in the slides and share with you. Many of the graphics and figures used in this presentation are courtesy of Rick Coleman and Brian Brettschneider, who I mentioned earlier, both associated with the National Weather Service, part of IARC. They're meteorologists, they're damn good scientists. Other graphics are courtesy of NOAA, NSIDC, other agencies, World Climate Service, for example, and they're indicated on the slides. I give the credit, as any scientist does in citing other work. Though these figures have yet to be published in peer-reviewed journal, they take time. They've got the referees, and etc. They do reflect the latest data and can be assumed to be accurate. So that wraps up part 3 of this continuing following of the developments of what's going on in Alaska and the Arctic since the summer. And I will continue with part 4 very shortly. So stay tuned for that. Thank you for your time. Hey folks, it's a reminder to please share my videos with others and to also please tell others of my channel. Please subscribe and don't forget to hit the bell so that you receive notifications when I upload new videos. I also hope that you will consider supporting the work that I do and supporting this channel by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.